and welcome to day 3 of Rapid Plus TCT 2022. I'm Brandon Ribic, the Technology Director at America Makes, and I'm happy to be joined this afternoon by Ryan Hayford from Xerox. How you doing?
I'm doing fantastic. Thanks, Brandon.
Good. Yeah, you're welcome. Yeah, it's really nice to meet you. We've been talking a bit about the technology that Xerox has and just trying to understand things. But I think, before we get to that, something that we've been talking a lot about this year at Rapid Plus TCT has been about the next level, right? Going to production. And as, hearing from folks in not only aerospace, but the automotive community, there's a talk of productivity, right? And I think there's a couple of variables there. And, so in your opinion, Ryan, is it that we need to think about more machines, bigger machines, is it the speed? And then how do we manage yield? Because we got to make good parts in the end, right?
Yeah, let's talk about it. So production to me is about scalability. And I think we define scalability in a handful of different ways, whether it's affordability, whether it's ease of use, whether it's access or throughput, all these different kind of characteristics, and every industry is a little bit different, right? So how would you define production or scalability? I guess my question back to you.
Yeah, so I think, for me, it's the ability to meet the demand volume at price, but also understanding the consequences of that as you go to that production volume on the feedstock that goes into the process, right? And your ability to push product out the back door, because often additive doesn't end with additive, right?
No, not even close. And I think the additive market in production is less than 1%, right, of the entire manufacturing market in general.
Sure.
So really, all of this conversation to me leads to qualification, right? Okay. Are we qualifying application by application? Are we qualifying part by part? And again, specific for every industry, but once we get to true qualification in certain industries, that's when we get to production. And I think one of the questions, again, I'm asking you now, but who do you think should own qualification? Is it the OEM? Is it the user? Or is it independent institutes?
I think ultimately, I think the working model right now is sound, if I had to say anything, and that is typically qualification is the product of a relationship, and it's typically between the supplier and the OEM. That is the entity or individual with the ownership and design authority quite often, and those who develop the requirements, and they understand the design features which go into the final product form and that application operating environment. They understand the consequence of the material, the geometry, and the inspection technology that then goes on to build out the certification criteria as well.
And in some environments right now, like the dental environment, right, they are doing true production with 3D printing, right?
Yeah.
There are technologies under this roof right now that are being successful to some extent, but we have not been able to scale. And price is one thing, absolutely, but I do think qualification is one of the biggest barriers. Of course, size, speed, throughput, materials are all going to be important considerations. So we, at our business, LM Additive, we take it very serious on behalf of the Xerox brand.
Okay, cool. So in terms of the technology that you're working on, tell us a bit about that.
Sure, so liquid metal jetting. We were one of the first commercially available metal jetting machines in the marketplace. We came out with aluminum, and that's the focal point is aluminum alloys right now. So it is a 4008 aluminum, and we're working on a couple more advanced alloys, and they're coming out in the works right now. But the goal originally was the spares and repairs market, right? Of course, prototyping, functional prototyping, short-run production, manufacturing, floor jigs and fixtures, aids, all those buzzwords we hear in the 3D printing industry. But the spares and repairs market, being able to do on-demand production with a safer and simpler technology like we have with the liquid metal jetting, that is the purpose.
So can you describe a bit more about the metal jetting process? I'm not very familiar with that. And there's a lot of different types of AM modalities. So what does that involve?
Absolutely, Brandon. And so basically, we work with aluminum wire feedstock, right? So it's actually welding wire.
Okay.
We put it up into the crucible and heat it up about 800 degrees Celsius, and then we drop it onto a nickel-plated brass build plate. And so you're looking at a molten deposit of material, about 800 degrees Celsius, like I mentioned, and then droplet on demand. There's actually an electric magnetic coil that controls the droplet deposition up to about 400 droplets per second. Pretty impressive technology. The beauty behind the technology, and hopefully we get a chance to share some sort of video with you guys, but a aluminum part printed on top of a nickel-plated brass build plate. Once it's finished printing, we throw it in a water tank, and the part separates from the build. And the part is finished. There is no sintering, there is no debinding, there is no shrinkage problems. It's pretty fantastic and elegant technology.
Yeah. So, thinking about the electromagnetic field, the droplets that kind of go through that, and the delivery mechanism, are you able to not only tailor the frequency of the droplets, but also the size of the droplets as well?
Size, not necessarily, but that is kind of the focal point, right? So right now we're looking at about a 240 micron size droplet. It comes down like a pancake format, if you can imagine it, right? But the deposition rate, yes, absolutely, and a lot of it depends on the part geometry. We're unsupported up to about 45 degrees, and then from there, depending on the intricacy or complexity, we will increase or decrease the amount of material being deposited. Furthermore, the material jetting wizards over at Xerox have integrated a few beautiful technology aspects, including a process monitoring. So every 5 layers, it takes a snapshot of what's going on, and then it increases or decreases the amount of material being deposited onto the part.
Okay, that's really interesting. In fact, we did a similar effort using a hybrid manufacturing process, so additive and subtractive, and in that we use some metrology to make adjustments, maybe do a little machining, and then reestablish the reference frame for subsequent deposition. It sounds like this is very similar, where you can adjust your parameters in order to maintain your GD&T requirements.
Yeah, you absolutely nailed it.
Okay. Cool, that's really exciting. So you mentioned aluminum alloys. Are you sticking to that? Is that going to be kind of your bailiwick, or are you going to go beyond aluminum alloys? Or what else
the sky's the limit, right?
Okay.
We've worked with a handful of different organizations, a lot of great partners. We're very proud of a lot of the partners that we have, but I can't disclose too much information right now, but good things are coming, and you talk to some of our partners, and a lot of them are in this room. They'll tell you that they think this has a really great scalability option from many different perspectives. So the future is bright.
So right now, what is the scale of the machine? So you mentioned that there seems to be good controls in place. You talked about the speed at which you can remove the part from the build plate, but how big are the parts that we're talking right now, at least with the current platform?
Yeah, great question, right? So we're looking at about a 300 by 300 by 120 millimeter build platform, right? So 12 by 12 inches by maybe 5 inches, something around those lines. We're depositing up to about 2.5, 3 pounds worth of material before we have to swap out of the head. So you kind of put it in perspective of what you're looking at. But essentially, because there is no crazy post-processing, right out of the bed, we like to consider it the fastest part in hand.
Okay, no, that's interesting, because I think folks have been talking about, how do we, maybe if the opportunity doesn't lie within the additive process itself, what other operations can we try to augment downstream, upstream, et cetera, from the additive process in order to speed up the productivity? So it seems like you're thinking about that.
We are, but I don't have the answer. Machining is, and everything else, that's secondary, right? Sure. But it is certainly a challenge that we collectively have to answer. Yeah. And again, I do believe that it eventually comes down to qualification. We want to be involved in critical and non-critical parts. Non-critical is kind of easy for us, but critical is going to take some time, and it's going to take the right partners and a collaborative effort between the OEMs, between the suppliers, between the customers, and the institutes. Why we rely on America Makes, actually.
Yeah, no, thank you. So, I guess one other thing I wanted to ask you is, thinking about your technology, the customers you're working with, the materials you're working on, you mentioned a lot about qual. Is there something there in particular that you think we as a community need to be focused on to help accelerate or drive efficiency in the qualification process?
I don't think I'm the right person to answer that question. Okay. To be completely honest, specifically focused on something is, I feel like the ball is always moving, and I've been an additive for the last decade, and I always felt like the customers were writing the book on additive, right? So applications are driving what's happening next in the industry.
Sure.
Sometimes I ask the question, is applications drive materials or materials drive applications? And I don't really have a great answer. What would you say?
It's usually a little bit of both. In my but limited experience, we did a workshop actually last summer And some of the conversation that we were fortunate enough to get into is, there's a lot of applications that folks have in mind right now, and I think there is opportunity to develop new materials. But with that comes challenges, right? I mean, there's some sayings about good intentions and this and that, and but that being said, I think keeping the end game in mind is very important. But I think we need to recognize, the limits to the current capability. That is the ability to make the materials that we need or we think we need. And then if we can derive that focus and that intent in agreement of what the end game is, and we know why we're doing what we're doing, I think we can be successful in developing materials in that sense. I think there are examples of groups that have been very successful doing that and utilizing a lot of different advanced manufacturing technologies, not just additives. So,
and I don't think we're fast enough. Every customer I talk to in this realm is saying, you guys got to get there faster, right? So, but we've got to do it correctly too.
Sure, absolutely. Well, Ryan, it's been great chatting with you. I really appreciate your time today, and I hope you enjoy the rest of your time at Rapid.
You got it. Thanks, Brandon.
Yeah, thank you.